Today's printed circuit boards often include embedded software or firmware as part of the design. The code is stored in microcontrollers or flash memory chips. If you outsource printed circuit board assembly to a contract manufacturer, you need to consider how these ICs will be programmed. Many devices can be programmed in circuit. This is common in prototype development. This makes it easy to iterate and troubleshoot the software in tandem with the hardware changes, but in-circuit programming is too time-consuming for anything but the first few prototypes. To speed things up a bit, we can use a universal IC programmer. Once an IC is placed in the programmer, it takes only a few seconds to transfer the data and check it. But it's a manual process to pick each IC, place it in the socket, start the program, and unload it when it's finished. An experienced production worker can program about 100 parts per hour. That's suitable for pre-production runs and some low-volume production jobs. However, as with any tedious manual process, when fatigue sets in, it's easy to make mistakes, such as missing the indicator that a device failed to be programmed. This leads to quality problems later on. It also adds a lot of labor costs to each part and takes skilled manufacturing workers away from higher value activities, such as assembly, inspection, or testing. So, higher-end, high-mix contract manufacturers may invest in robotic handling systems to automate IC programming. The operator loads a reel of parts or a tray of parts and starts the system. The SuperBot automatically begins loading and programming ICs. It tests each one to verify that it's programmed and sets aside any that need to be redone. It can test that same 8-bit device we showed earlier at about 2,100 parts per hour. That's 20 times faster and with almost no labor cost. The equipment investment for robotic IC programming runs from $70,000 to more than $400,000 for systems that can handle the small SOT23 packages commonly used for microcontrollers. The payoff is higher throughput, lower costs, and error-free programming. Another option is to buy pre-programmed ICs from your parts distributor or a programming service. You send your firmware file to the IC distributor and request a first article for testing. The lead time for production parts is typically 3 to 4 weeks after first article approval. This means if you have a new product, or even just a firmware update, you'll be waiting several weeks for programmed ICs. In contrast, with automated IC programming in-house, your contract manufacturer can be running production parts with your updated firmware the same day you send us the file. We found automated programming costs about 50% less than manual programming and 30% less than buying pre-programmed ICs in the low to mid-volume quantities our customers need. So at Z-Axis, we combine in-circuit and manual programming for prototypes and pre-production runs with automated robotic programming for production. It's one more way we deliver lower costs, higher throughput, and highest quality for our customers.